Welcome back as we continue our wonderful journey in core mathematics. My name is Nanaya Edu, and you can call me Sir Nana. Remember to like this video, share this video, comment at the comment section, subscribe to my YouTube channel, and click on the notification bell so that you can get all videos on time. In my previous lesson, we have considered examples on the Pythagorean theorem, where we've looked at how we can find a side of a right angle triangle when other sides are given. In this lesson, we want to consider how we can solve application questions on Pythagorean theorem. Remember to have your calculator and your jotter on the side so that you can practice as we practice along. Now let's consider one of the questions. So in this question, it says that Agnes is placing a ladder of 41 meters long on the ground in such a way that it touches the top of the vertical wall, which is 40 meters high. She is wondering to find the distance of the foot of the ladder from the bottom of the wall. Can you help Agnes? So let us help Agnes in this sense. So basically, we want to visualize a question. Mostly when you get questions that are application related, all that you must do is to first try and understand the question, and then you visualize it as much as possible. So let's consider how the question can be visualized. So basically, we are saying that Agnes is placing a ladder on the wall. So let's draw the wall. So let's assume that is our wall, right? It's a very tall wall. And then we are putting a ladder on the side, right? So Agnes is placing a ladder on the side of the wall. So let's assume this is our ladder down to the bottom, right? So we have our ladder. So it moves from the side here down to the bottom, right? Now, it says she's wondering to find the distance of the foot of the ladder. So we have the foot of the ladder here. Let's assume the foot of the ladder is here, which is A, to the wall, right? So the foot of the ladder, which is here rather, right? The foot of the ladder is here, which is A here, right? This is the ladder, the red one. And then this is the wall. So let's call the wall B. So we want to find the distance from A to B, right? So let's sketch a line here. That is fine. So now we know that the ladder, or the length of the ladder, is 41 meters. And then we know that the vertical wall where the ladder leans against, the length from that side is 40 meters. So we are finding the foot of the ladder, which is A, from the wall, which is B, right? So let's label the top part here as C. So it means that based on Pythagorean theorem, we can say that AB all squared plus BC all squared is equal to AC all squared, right? We are finding our AB squared because that's what we don't know, plus our BC squared is 40 or 40 meters, but we'll not bring the units, we'll bring it after we find our final answer, right? All squared is equal to AC, which is 41 all squared. So now our 40 squared, which is 40 times 40, when we use our calculator, we know that that gives us 1,600. And then 41 all squared, which when we use our calculator, we know it will give us 1,681, right? Then plus AB all squared, right? So in order to find our AB alone, it means that we are going to have 1,681 minus 1,600. So it means the foot of the ladder AB, right, should be equal to 81, the square of AB, right? So when we take the square root of both sides, take the square root of this side, and we take the square root of this side, we know the square root cancels it. And then that means that our AB, because it's a length, will give us 9. 9 what? The answer is in meters, so 9 meters. So in this case, we can say that we have helped Agnes to find the foot of the ladder which is 9 meters. Now let's consider another question now. So in this question, we are saying that the pole of a sailing boat is supported by a rope from the top of the pole to an anchor. So we have a rope of a sailing boat supported by a rope from the top of the pole to an anchor, right? And point on the deck. So the pole is 4 meters long, right? So we can use our ruler and then we'll put the pole as 4 meters. So we have our pole here. Let's say it's just 4 meters, right? So that is our pole. Now the rope, which is probably, for ropes, we could put it from the top here, right? And extend it down here, right? And then we can join. Once we join, realize that we form a right angle triangle here, right? And they say that the pole is 4 meters long. And then they've also given us the rope to be 4.5 meters. So 4.5 meters. Now we are asked to calculate the distance from the base of the pole, which is here, right? Let's call it X, to the anchor point of the rope. So this is where the anchor point of the rope is, Y. So we can call this side, let's say Z, right? So from Pythagorean theorem, we know that xz all squared plus xy all squared, which is the square of the length of the opposite sides, is equal to the square of the longest side, which is 4.5 all squared. So we know that xz is 4 meters all squared plus xy, which is what we are finding, all squared. Then we have our 4.5 all squared. So we know 4 squared gives us 16 plus xy all squared, right? So that is xy all squared is equal to, we have our 4.5 all squared. So that should give us 20.25. So that implies that our xy all squared should be equal to 20.25 minus 16, or you subtract the 16 from it. We have xy all squared to be equal to 20.25 subtracted from 16. That should give us 4.25. So our xy should be equal to the square root of 4.25. So that means that our xy should be equal to the square root of 4.25, which actually gives us 2.06. 2.06. Now the unit is in meters, so we'll end with meters, right? So that means that the base of the pole, right, x to y, is 2.06 meters. So these are application questions, and that is how you go about solving them. Now let's consider this one as well. So in this case, you are asked to work out the length of the diagonal of a square with 8 centimeter sides. So we are given a square and you are given a side of 8 centimeters. So let's sketch the square in this case. So we know that for square, all the sides are equal, right? Not drawn to scale. So we know that all the sides of the square here are equal. So if here is x, here will be x, here will be x, here will be x. Now we've been given our side x as 8. So this 8 centimeters. This is 8 centimeters. This is 8 centimeters. And this as well is 8 centimeters. So we want to find the diagonal, right? The length of the diagonal. So a diagonal is just a line drawn from one side to touch another side on the diagonal. So that means that we get a right angle triangle, which you can see over here. So one side is 8 centimeters, which is here, right? And another side is 8 centimeters, which is here. And then the hypotenuse is what we are finding. Let's call it x, right? So based on Pythagoras theorem, we know that s squared should be equal to 8 squared plus 8 squared. So it means s squared is equal to 64 plus 64. So when we add 64 plus 64, that should give us 128. So x squared is equal to 128. So we can find the square root of both sides where this cancels this, and our x becomes equal to the square root of 128, which actually gives us 8 root 2. So 8 root 2 centimeters. Or better still, we can write the decimal point, which is 11.31 centimeters. So that is the diagonal that we have found. So in this lesson, we have basically gone through the process of looking at some application questions in relation to Pythagoras theorem. We've seen how we can solve application questions. You visualize it, you write out your information, and then you find what they are asking you to find. In our next lesson, we are going to begin a whole new topic. We are looking at vectors. Ensure that you like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.